In this video, I'm going to do some experiments on electricity, most of which were done in the 19th century to 20th century. Here I have a voltaic pile, and it's made up of plates, lead and lead oxide plates. So what I'm going to do is take a wire, just an ordinary wire, and I want to see what happens when I have this near the magnet. Okay, 1, 2, 3. Whoa, the wire appears to move. It's crazy. So, if I can get the wire to move when I have a magnet near it, what if I move the magnet near a coil of wire? So that's what I have here. It's basically just a coil of wire, and over here I have a galvanometer, which is used to measure charges, well, small charges. So if I put this near the magnet, theoretically, I should be able to get some electricity. So I'll just, nothing. Wait a minute. When I move the magnet, the needle appears to move just a little bit though. That's awesome. So what is happening here? The magnetic field of the magnet, the neodymium magnet, is being transferred into the coil, which then produces electricity. So I was wondering if I could make a battery now out of copper and zinc. So I'm going to make a battery here. As you can see, I have a copper plate and a zinc plate. So what I'm going to do is take the copper plate and put a piece of filter paper on it, and then I have a lime. Can also use lemon or even vinegar. Vinegar obviously works best, and just squirt out a few drops of juice on it, and then put the zinc plate. So, and then I'll use some clothespins to keep everything shut. Okay, I have the finished battery, and let me connect it to the voltmeter. Positive is the copper plate, and the negative is the zinc plate. Ooh, as you can see, I'm producing about 1 volt of electricity. That's awesome. With just a lime and a zinc plate, I'm producing electricity right now. So I wonder if I can use this electricity to do some actual work. I don't think it'll run this motor. It runs on 5 volts. So I need a better load to test it on. Oh, what do I have here? It's a resistor. What a resistor is basically a device that limits the current. So you can find a resistor in most electronics. So I'm going to put the resistor on the zinc and copper plate, and see the different change in the voltmeter. There appears not to be a change. Let me quickly just clean up this resistor. Okay, here I have the resistor once again, and let's see if it, okay, as you can see on the voltmeter, when I put the resistor across it, there'll be a change in voltage. You just have to get the connections right. As you can see, you have a small drop in voltage, and this is a 1 kilo ohm load. So we can calculate, wait, not a 1 kilo ohm. What is this resistor value? Not sure. So what I'll do is that I'll take a 2.2 kilo ohm load instead and see the difference in voltage now. There appears to be no change in voltage. Why is that? The connections are really strong. I don't know why it's not changing. Oh well, it's probably not in enough load. So I would take a 2.2 kilo ohm resistor, but a 6 watt, a 10 watt one, I mean. Ah, yes, this is the result I wanted. As you can see, the load causes this amount of drop in voltage. So now we can calculate the amperage using the resistance, and I'm guessing the change in voltage. So I'll be back. What are you doing there? Hmm. Huh? What are you doing? Anyways, so yeah, let's calculate something. Okay, for the current, 1 volt divided by 2000 ohms. Okay, so that's 0.00045454545. Well, whatever. It's a recurring decimal. So I'll put. Let's calculate now. Since we have the current, we could calculate the voltage using the current, I'm guessing. Okay, so let's just put 0.4. How do you delete on this thing? Okay. 0.000454. Okay. Times 2000 ohms, which is equal to 1 volt. When you round it off, of course. Yeah, it's 1 volt. Okay, so my calculations are kind of correct. I want to see what happens if I put all the decimal numbers. So if I put 0.00454545454545, and then decide to put 6 times 2000. Okay, we get 1. Yeah, 1 volt. So that's the voltage. Just making sure that the current is correct.